Hello to my friends, welcome to Gtcaad. Today we have the very important practice in SolidWorks. As you see, I model a shaft. In SolidWorks also I did draft a drawing of this shaft. This practice supports all levels in SolidWorks. For example, you are an advanced user in SolidWorks or intermediate, or you are just a starter to learn SolidWorks. It's so important because it boosts your industrial manufacturing based on a CAD software. I put this PDF file, also the SolidWorks file, in Telegram channel. The link is on the description. Just go to the description and tap the link and download the PDF. This is the result of this shaft. Okay, let's go to the model this shaft in SolidWorks. Press Ctrl and hold it and press N key. Create new parts. Create a sketch on a front plane. Okay, here resize. Okay, let's to magnify the drawing in the right side of the windows. Drag it right and click the SolidWorks windows. Zoom out to watch all shape of the shaft and it's okay. Okay, let's create the first. We need to create a center line to rotate our sketch about the shaft. Here I want to make a dimension. The center line length is the length of the shaft 997. Dimension it 997. Okay, I want to start from the left side. I zoom in. The first diameter we need to start is 80 in 87 lengths. Start with the line, create till here. After that, continue the sketch till here. The dimension of this first diameter of the shaft is 80 and the length is 87. After the 80 we have the 85. The length is here. 85, the length is here, 144.6. The diameter is 85. The length of this point till origin is 144.6. Okay, before this point we have the detail number B. The detail number B shows us we have the groove cut extrudes on the shaft. This is the detail of the groove. We have the angular line that has 30 degrees about the horizontal line. After that, 3.4 is the length of the groove. And finish with the radius 1.6 in the depth 1.5 millimeters. Okay. Create this groove. I want to delete this dimension. And I want to, for example, I drag it the points a little to left side. Okay. Start with the angular line. After that, straight line. Drag it here and back to previous point. It start to create a curve. After that, continue till here. Right click on this point and it should be tangent with the versus line. The degree about the horizontal line is 30. The length of the straight is 3.4. Here the depth of the groove is 1.5 and the radius of the groove finishing is 1.6. Okay, after that This point from the origin is 144.6. Okay, this line and here is 85 as I said, and the next diameter is 90. This line about the center line is 90 millimeter. Okay, the length of the 90 millimeter is here, 236. This point, I can drag it the dimension till here to make a little space. This point till origin is the length 236. Okay, after the 90 we have the diameter is 105 in the 360 length. Choose a line. The diameter of the line is 105 millimeter. The length is 360. 360. Okay, after this diameter we have the 108 diameter in 20 lengths from the previous step. Again, use a line. Here the diameter is 108 millimeters. The length is 20. Okay, after this diameter we have 110 diameter. Again, use a line. $110 millimeter. Okay, here we don't need to make a length because the total length can calculate this length. Okay, I leave it. It doesn't need to dimension it at this time. After this diameter we have the 95. The diameter starts to smaller, and after that we have the 80 diameter. Okay, this diameter is 90. After that we have 80. Here. Okay, drag it this point till here. Again till here. After that we have the chamfer. Create an angular line to refers to our chamfer. After that we have this shape. Okay, I want to dimension it, the chamfer first. The angle is 15 about the horizontal, 15 degree. The length of the chamfer is 5. And okay, I forgot to create here. Let to change after the 110 is 95. Edit it. 95 after that is 90. After the 90 we have 80. 90 till here. Okay, let's do trim it. It doesn't matter, we can re-edit it. Drag it till here, for example, and continue sketch with 80 diameter. After the AD starts with chamfer, the length of the chamfer is 5 here. Okay, the angle of this line about the horizontal, we have a problem here. To check it, it deletes the parallel relation. Okay, dimension the line about the horizontal axis should be 15 degree. Okay, delete this line and continue the downside. After that, this right line. Okay, this diameter about the center line is 70 millimeter. Okay, after that we have the M60. It means the diameter of the shaft needs to be 60 to create a thread on the shaft. But before that, we have the detail number A, and it shows us again another groove on this diameter. Okay, I zoom in to show you. Here started with the radius, after that the straight and angular line. The detail shows us here. Use a line, drag it to downside. After that, back to the point, started with the radius. After that, a straight line and angular line, and continue here. Right click on this point, it should be tangent. The angle about the horizontal line is 30. The length of this line is 3.4. The depth of the groove is here, 6.5. After that, the radius of this curve is 1.6. I forgot to dimension it. I create this point in relation tangent. Okay, after that, here the diameter of the shaft to create a thread is 70. Dimension 70. Okay, close the sketch on the center line and make a relation in length. Next length is 122 millimeter. In the groove is fixed. It doesn't need to make a dimension, but the next length is 122 from the start of our chamfer. Here to here is 122. After that, the end of the AD diameter is 422. This line and here is 422. Okay, drag all dimension till here, make a little tidy. Coincident this point and the center point should be merged. Okay, it's better. The next is 461 millimeter for this diameter. Here, this line and this line of the right side of the shaft is 461. And here the next is 504 for the diameter 95. Find the 95 is here. Okay, this is our last dimension. Till here is 504. Okay, I magnify the windows of the SolidWorks. As you see, our sketch is black. The sketch is fully defined. I created all dimension we need. Let's drag it here to close to his diameter. Okay, go to the feature and select the revolve boss base. It warns you the sketch is open. Would you like to close it? Yes, it automatically does it for you. And okay, our shaft is created. Okay, here we have the problem. Let's re-edit the sketch to find the problem. Okay, about the 70mm diameter. Delete it. Let's check it again. Here from the start point of the groove is 14. Here. Before that we have 70mm. Here is 60. Okay, I made a mistake here. 70. Change it to 60. Okay, exit. It's created. Our shaft is created, but other detail remains. To change the material, right click and in the search box E45 or C45 is here. The standard DIN of the CK45 material is 1.1193. Apply it. Okay, the material is changed. In drawing, here we have the key slots. The AA section view is here. The depth of the key is 75 and the length of the key is 70. The width of the key is 22. Okay, to create on the shaft we need to create a plane. Click on the plane. Here select the front plane, the first reference. After that select on this surface of the shaft. It should be parallel. Okay, I create a plane that is tangent on the surface and click on the plane. After that create a sketch. In this toolbox we have the straight slice. Click on it and drag it a straight slice. The width is 22. Here to here is 22. Okay, the length of the slot is 70, but it is the maximum length of the slot. Here we have the tips. I told you, select the smart dimension, tap one of the slot or hold on it. The yellow point, it's the midpoint of this curve. Select on it. After that drag or hold on your flash dimension on it. Another yellow point is created. Again select this point and it shows the total length of the slot and change the amount 70. Select this point and the origin should be in a straight axis and should be horizontal relation. Just one dimension remains. The space smart dimension, just hold, and when the yellow points appearance, click on it, and from this face is 9mm. Okay, back to the drawing from the plane described, and here this is the depth of the slots. AA section, here is AA section. From the bottom of the shaft till the depth of the slot is 75. Complete circle of the shaft is 80. 80 minus 75 is equal 5mm. The depth of the key is 5mm. Back to SolidWorks. Go to the feature and select the extrude cut and change the amount 5 millimeters. Okay, hide this plane, we don't need it again. Another slot is remains, it's the right side, it's the 90-degree located from this slot is here. In the section BB I show it here. Okay, here in section BB I show the key slot, the width is 22 and the depth is here 66.4 from the bottom of the shaft. Okay, let's do create it. Back to SolidWorks. Here and go to the evaluate, measure, this diameter is 70. We need to create a slide on this diameter 70, but it should be 90-degree located from this slot key. Okay, choose the top plane. Okay, I selected 2 planes. Look, front and top is perpendicular to each other. Select the top plane, create a new plane, and select the second reference on this diameter. But it's also should be parallel about or perpendicular about this slot. Okay. Go to the sketch, create a 2D sketch, and select the slot key. The width is 22. Select these points, and the origin should be relation in horizontal. As I said, the depth or have the offset from this line and here. These points. When you press shift key, it automatically select the near point of these slots, and it should be 9 millimeter. And from this point, or the total length of the slot key is 70 as the previous key, and the depth is here. The depth of the slot is 7 minus 66.4 is here. Calculate, you can calculate in your mind, but I want to show you how to calculate the depth. 66.4 is equal 3.6. Back to SolidWorks. Okay, this is our sketch. Go to the cut extrudes. The depth is 3.6 millimeters. Okay, hide it. Here the threads and the holes remains. I want to start from this face or the right side. Here we have M60 in 1.5 pitch. Go to the hole wizard. Under the hole wizard we have the thread. Select on it. Here it wants us to start the locate of the thread. I select this edge. The end condition should be on up to selection, and select this edge as the end condition of finishing the thread. The types of the threading is metric die, it's not the metric tab. The tab is 4 holes, and the size is M6 in 1.5 pitch, and the thread method, it should be cut threading. And okay, our thread is created. Here, go to the left side. Here we have the thread. The dimension of the thread is M90 in 4 pitch. Okay, it should be 90. The diameter is 90. Go to the evaluate and find the 90 millimeter diameter. Here the diameter is 85. It's not that. Again, select the next. Diameter is 90 here. Okay, and it starts from here. Go to the sketch. We need to make a groove for our thread. Okay, delete this diameter. I want to create a rectangular, it's like a standard groove to start our thread. The width is 1.5 and the depth is again 1.5. From the start of our thread, select this line, and here is 107 millimeter. Exit. Okay, here this is the start of our thread. Go to the feature, under the hole wizard, select the thread. Okay, here the thread location is here, this edge. The up selection is here, this edge, and here is M90 in 4 millimeter pitch. Okay, our thread is created. Okay, again edit the sketch. Let me check in. Okay, this parameter is distribute. Delete these steps. This line, let me check and delete it. Make a dimension this line. Here is 45. It means the diameter is 90. Okay. The depth is 1.5. Also, you can create a fillet except this groove, but it's work. Okay, go to the thread, re-edit again, and change the up to selection, change it here, this edge. Okay. Okay, our thread is created, just remain the hole. Save it. Go to the drawing again. From this side, we have 1, 2, 3, 4 holes. The pitch diameter is 40, and this is the specification of the hole. This is the countersunk diameter. Hole is 14 in 90 degree, and the thread is M12. Okay, select this face, normal to view. Go to the feature and tap the hole wizard. Okay, select the right tab, scroll down, the standard is ISO, the type is bottoming thread tapping hole, the size is M12, the length of our thread is 30, and the hole length depth is 40. Scroll down, with thread callouts should be activated. Also near side countersunk you can re-edit into 14 millimeters the diameter of countersunk, and 90 degree is our angle countersunk is sorted. Go to the position, just tap this face and select 1 point. Escape key, create a circle till coincident with this point. It should be this circle for construction because it's temporary circle. We doesn't need to just dimension it. And here the pitch diameter is 40. and make this point, and the origin should be in a straight vertical relation. And okay, one of the hole is created. Click on it. Under the linear pattern we have circular pattern. In the direction select on this shaft should be rotate for samples of this feature. Okay, our holes and our keys, also our threads is created. Okay, to create a drawing or get the drafting of this shaft, go to the second option, make drawing from the part or assembly. Click on it. Here the standard sheet size, scroll down. Each core company or each users need to have the sheet standard based on the company's defaults like names, company's logo or description. I made it as a Gtcaad template. Okay, I drag the front view and drag and drop it on this sheet. Okay, let me to show you the description or the border sheet of the Gtcaad. Here, this is my design of the sheets drawing. I put the ISO tolerance. It's a common tolerance. If any dimensions doesn't have any tolerance, you can look at this table and choose the tolerance for that dimension. And other description of the product here, material notes or other stuffs like this. Okay, this is the front view of the shaft. Click on it. The left drawing view toolbars activate. Here we have the standard view. All of the standard view you can change it. For example, if you drag it on it, it shows you its left. After that, in display style, we can make it in color material, also without any shaded line, but the common drawing view is here. Display start is hidden lines remove. Okay. Under that, scroll down. Here, this is the scale. You can magnify your view of your workpiece. Use the custom view. It's based on my scale. Okay, here in the default we have some scale, but if there is any scale that you want doesn't exist in there, you can change it by your description. Delete it and I change it to 1:3 scale. Here in this part of the shaft, this is the huge or too long length of the shaft. I want to cut it to increase the space between the shaft and the border. Go to the drawing tab, select the break view. Just select this view to recognize. Here the cut direction, I want to cut it from the vertical direction. Also here we have the horizontal direction, but it doesn't work at this front view. And select, for example, I cut it from this part to these parts. Okay, it's make it a little shorter. Okay, in the drawing just select the front view. It's create or project from this view. Here I can see the holes from this view. This is the left view of this shaft. Okay, let's go to the dimension this shaft. Okay, I want to start to dimension all diameter of the shaft without any tolerance. The first, after that I run the tolerance all on all dimensions. Okay, go to the annotation, smart dimensions like sketch tools, and dimension. This line to here is shows us the AD diameter of the shaft diameter. Okay, here we have dozens based on my fonts. I want to change it. Also remove all zero after this dot. Go to the option, tap the gear sign, go to the document properties, click on the dimensions. All settings about the dimension is here. Change the font and type it TIM, Time New Roman. Okay, scroll down, and here to remove all zero after the dots, just in dimension remove it. Okay, the font change and all zero after the dots dimensions remove. The next diameter is here is 85. Just drag it till here. After that, here we have 90. One 105. 108. 110. 95. 90. 80. And also here we have the groove of the slot. Just select before that. 70. The diameter sign should shows the dimension. After that, for example, to dimension the thread, just select the top thread shape till the down opposite side here. Okay, it shows the diameter sign. You can change it. Just divide it in the dimension text. Just divide it. This DIM. Drag it the left text and delete. Select the left. Okay, it's activate the left side to create a sign. I want to write M. Caps lock. Activate and press M. Write M. M6. Okay, click after the DIM text and let's deactivate the caps lock and write X. After that 1.5. Let me check in. Is 1.5 and M6. Okay, you can change the fonts smaller to fit on the dimension size. Deactivate the use document font and make it in this point should be, for example, 12 dimension. Okay, it's better. Here this thread remains. Select the shape of the thread and it's automatically drag it to the left side again. Do it for it. Delete and write M, caps lock M, and space X space. I think it was the pitch was 4. Let me check. Yes, M90 in 4 pitch. Okay, you can reverse the flash of the dimension to be inside it. Okay. Here the total length of the slot groove is here. Select one of the fillets of the groove, press and hold key. After that, when you click on the here or hold it, the 70 shows us the total length of the groove, length of the slot key. Again, select this line and press and hold shift key. After that, hold it. The none should be shows us. Okay, drag it to left side. After that, go to the drawing tab. I want to show the depth of the slot key. Use the section view, and it should be vertical direction. For example, section view from here. Okay, and drag it to the left side till here. Okay, you can change the font into Time New Roman, write TIM. Okay, when I drag this view of the section, it just move around horizontal axis. Section view in alignments, break alignments. You can moving this view anywhere you want to locate it. Okay, I want to locate, for example, here. This is the section AA, but here is shallow. And okay, the connector activate. Do it for the right side, the slot key, section view, and drag it till here. You can reverse the direction. For example, flip the direction till here. When you flip the direction, the right side will be deleted. It means I can see the thread. It's simple and it's better. Change the font. TIM, New Time Roman. Right click on the section view, alignment, and break the alignment and drag it here. Okay, as you know, I created two groove cut extrude. I want to dimension it, but it's so small when you zoom out, or in this paper the operator doesn't recognize or doesn't see the dimension of this groove. Okay, I want to use to magnify the dimension of this groove. Use the detail view. Select on it and select, for example, here, and drag it till here. Drag this view in the bottom of the shaft view, and let's change the style. Okay, I zoom in to show you. Here, this is the C detail. Change it to A. It's better to change from the A, B, C, D. It's better to start it from the C word. Change the style with letter. It helps you to find your detail fast. And change the document time, and okay. Here still our view of or magnify of the drawing is still smaller. To change it, we need to change the scale of it, and scale, for example, 2 times bigger than the ordinary view. Here it's better. Also, the right side we have another here, groove, magnify, and drag it here, and it should be 2 times. Change the font, TI, and okay. Scale it in 2 times bigger. Okay, make it a little bigger. Okay, save it. This detail should be with letter. Select the detail and change it with letter. Okay, drag it the length of the slot key to downside. Okay, I want to make a dimension about the length of the shaft. Go to the annotation. Under the smart dimension we have to baseline dimension. Just select this face of the shaft. It should be our started point. Select this line, the end of the groove, this line. It's automatically dimension it till here and escape. Drag it all dimension, one of the dimension. When you drag it into downside, the others comes with it. Okay, drag this view to downside to make a little space between the dimension and our views. Again, use a baseline, this line here to first start groove here, here, and here. Drag it to downside is here. Okay, delete one of the dimensions, extra. Okay. When you click, just single click on this dimension, the right sign activate. When you drag it here, the small toolbar parameter, I want to select the center dimension. My dimension, look at the center of this dimension. Okay. The total length of the shaft remains. And drag it a little to top. Or make a dimension the depth of the, press and hold shift key and select the shaft here. Again for the right side, here to press and hold shift key until here. The diameter, I dimension it from the here, but I want to show you which diameter I did the slot key on it. It shows us the radius sign. Go to the letters and change it into diameter, and it should be short letter. Scroll down, activate custom test position, and the second is broken letter horizontal text. It's look like this, and it's temporary, or it should be on parentheses. Again for this groove, again for this slot key, letter, diameter, short letter, and it should be here like this. Select on it again and use the parentheses. I dimension it. The width of the slot key here is 22. Let me show. Do it again. It's a little distribute. Use a smart dimension. This line till this line is 22. Okay, but for this width we need to dimension it on the section view here. This line and this line should be 22 millimeter in width. Okay, all dimension we need to create it on the front view is complete, just the left view of the shaft is remains. I want to show the specification of the holes. Here we have the hole callout. When you select on it or select one of the lines of the hole, it automatically shows off the whole specification. It's so easy. Choose the smart dimension and dimension the diameter of the pitch, but its radius, change it in the ladder tab into diameter. Also the second option, and it should be short ladder. Okay, all dimension that we need is created, and another dimension we need to create it is here. Before to create or dimension the tolerance on each dimension, just we need to dimension the grooves. The radius is 1.6. Short ladder, and the second item. Okay, drag it till here. The straight line is here, 3.4 is the length of the straight line. After that we have here this line, and here about the horizontal is 30 degree. Again, do it for it. Ladders, here, and angle. Click on it and it should be the middle of the dimension. And let's do close the radius dimension to view. Okay, just here 9 millimeter, and cut the extra amount of the 9 remains. Drawing, I didn't tolerance about the lens dimension. I just use the dimension to use the general tolerance ISO 2768. How can we use it? I'll show you. If my length is 87, the tolerance of the 87 is here. The 87 is put between the 30 millimeter till 120 millimeter. Okay, you scroll down. Okay, this is your tolerance, and which one is blind to 87 millimeter tolerance? Let's look at the grade of this general tolerance. I put a star to choose the M grade of general tolerance. Scroll right, and here about the 87 general tolerance is plus minus 0.3 millimeters. Okay, each drawing detail should have this table of the ISO general tolerance. Okay, we leave all the lengths without any tolerance. Let's do tolerance about the diameter. This is the first tolerance. We have the 22 is the JS6. Here this tolerance belongs to key slot GS6. Okay, back to SolidWorks. Tap this dimension. The left description of the dimension in the tolerance precision, select the fit with tolerance. GS6 is the fit tolerance, and I want to show the tolerance of this fit. Okay, select on it. Another box description appears. We have the two choice. One of them, when I drag my flash on it, it's for the whole fit. The second option is for the shaft. Okay, our slot key is whole. Okay, it's a shallow. Here select this toolbar and write GS6. GS6 is here, select it, and it automatically shows GS6 with tolerance minus 0.01. The up tolerance is plus 0.01. Okay, this is our first make the dimension tolerance. Back to the drawing here. The second is belonging to this diameter 80. Here the tolerance is 0 to plus 0.02 millimeters. Also it has the geometrical concentric tolerance about the A and B datum. Okay, the first I want to create this tolerance except the geometrical GDandT tolerance. 0 to 0.02 millimeters. Okay, back to SolidWorks. Here I find 280 diameter is here. Okay, drag it till here and drag it to up to have the more space. Okay, select the first option. Tolerance type should be bilateral. Select on it. Here, this is the minimum variation. The up is maximum variation. The minimum is 0, the maximum is 0.02. And click. Okay. Let's see that. Okay, it's apply. Here, some dimension has this same tolerance, like 105 millimeters has this tolerance, and also 95. And let me check in another. Okay, 1, 2, and 3 diameter has the same this tolerance. Okay, it doesn't need to create this tolerance by one. Here we have the tips. Select this dimension. Also here in annotation we have the format painter. When you click on it, it's copy all format of the tolerance about this dimension. Okay, back to drawing. About the diameter 108 and here 95, 110, 108, 95, 108, click on it. Okay, it's apply, and 95, it's apply. Okay, we have the 3 diameter that has the same tolerance, bilateral. Okay, let's continue. Another is here. This is the 90 millimeters of the diameter. This diameter is to sitting of the ball bearing, because we have the round shape, GDandT tolerance. Also we have the runouts about the A and B. Okay, here we have another tolerance fitting M6. Let's do apply it. 90 drag it a little top. Okay, the tolerance type is fit with tolerance. Here I want to choose the shaft type because it's the diameter on the shaft, and search M6. Okay, it's apply. Continue. Here the 81 is remains is 0.1. Sorry, the maximum is 0.05 and the minimum tolerance is minus 0.1. Click on the 85, and the third type is bilateral. You should type the minus sign the first, after that 0.05 and 0.1. It doesn't need to write the minus sign. Okay. After that we have the 105 millimeter diameter. The tolerance about it is the minimum is 0, the maximum is 0.02. Bilateral. Let me check in again. It's 0.02 and the minimum is 0. Okay. The next is 110 millimeters. It's symmetric, plus minus 0.1. Click on this diameter, and the types of the tolerance is here, symmetric. 0.1. Okay, we have the 0 after the number. If you want to delete it, just here in the unit precision, you want to select the first. It counts just the first number after the point. Okay, the 0 after the number is deleted. Okay, after that we have the 90. Let me check about the 90. Okay, this diameter uses the general tolerance. The tolerance of the 90 is here. Between the 30 and 120, 90 is this tolerance, and it's M. Scroll right till here. The 90 of the diameter is plus minus 0.3. This is the 90 tolerance. Okay. The next is 80. The maximum tolerance is 0 and the minimum tolerance is minus 0.05. 80 here. The third type is bilateral. The maximum 0 and the minimum is 0.05. Okay. The next is 70. It's use M6 like here. 90. 70. Fit with tolerance again. It's on the shaft. Click M6. Okay. The next remains, let me check it. Okay, all diameters have tolerance. I want to start with the GDandT tolerance. If you look at the GDandT tolerance like concentric or runout tolerance, it refers into A and B datum. Where is the A and B? The B is sitting on this diameter, 90 millimeters, and the A is sitting on this diameter is 70. This diameter 70 and 90 is so important to build this shaft because we have the two ball bearings which are sitting on this shaft diameter. Okay, because of that we put this datum on this diameter. B90, let to find the 90 diameter is here. To create a datum, here on the annotation we have the datum feature. Click on it. The label settings is A, and this is the leaders. It refers to here, the first one. Okay, it's you can freely moving this datum sign and just click on this line of the diameter and drag it down. Okay, to change the font of the datum, go to the setting. In the search toolbar, search datum in annotation. Okay, it belongs to datum setting. Change the fonts, Time New Roman. Okay and okay. The font change. Here in the 70mm we have the datum number B. I think it's a B. Let me check in. Yes, it's B, not A. Okay, I change it to B. Okay. Again, click on the datum feature and drag it till here. It's A. Change it, the label, into A. I want to drag the dimension to downside a little. Okay, it's better. Also about the details, should have more space about this dimension. Okay, we create two datums on two diameter of the shaft. After that, create all geometrical tolerance. The first, on the 80 millimeters diameter, we have the concentric. The amount of the tolerance is 0.02 and it should be concentric about A and B. In annotation tab, we have the geometric tolerance. Click on it. After that, directly click on the AD diameter. And okay. Drag it till here. After that, I fixed it in the right way. Okay, click on this square box. It refers to the geometrical tolerance. Change the direction. It should be set vertical. Okay, double click on it. We have some add sign here. To add it, okay, here the tolerance types. The bottom left side we have the concentricity. Select on it. After that, new Windows shows us the amount of the tolerance. Change it to 0.02, and here we need to create a datum. Okay, before that, select the diameter sign. It should be concentric in diameter. After that, we need to add the datum here. Click on add the datum and select the A and write B. Done. Okay. Our geometrical tolerance is created. Just change the font. Click on it. Scroll down and unselect the use default font and change it into Time New Roman. It's sharp and better than other fonts. Okay. Here we have some copy of this tolerance on the other dimensions, diameter, like 105, 95, and that's it. 105 and 95. Okay, to copy of this GDandT tolerance on other dimensions, just select on the GDandT and press Ctrl C, copy of it, and Ctrl V, paste. Okay, again, Ctrl V. Okay, create another. Drag it and drop on this dimension. Okay, just change the direction of the GDandT and set it in the vertical axis. Okay, here. Another was about 95. Let me check it. Yes, 95. And drag and drop on this dimension and change set in vertical. Okay. After that we have the two GDandT. One of them is refers to for the round form. Before that we have the runouts about the A and B. Let's to create this GDandT tolerance on 70 and 90 diameter. Okay, select the geometric tolerance and drag it here, and this is the first geometrical was circular runout. The amount was 0.02 and shoot the datum A and B. Done. Change the fonts, time, New Roman. Okay. Drag it and drop it on this dimension and change setting to vertical. Also, you can change the dimension letters in here. It's better. Okay. Click under this GDandT tolerance, double click, and here add another GDandT. I want to add it a new frame, and it should be circularity. Click on it and change the amount 0.02 and done. Okay, it's done. Click on it, Control C, copy, and here Control V. After that, drag and drop on 90 diameter. Let me check in. Okay. Let's to magnify the surface finishing here. This is the sign of the surface finishing. 0.8 refers to grinding of this shaft. Here we have the on the 70 diameter, also here 95, 105, and okay, we have just on 3 diameter the surface finishing. And in the drawing sheet I can see the roundness. The DIN ISO is 1302. The bigger or greater than the 0.8 is 1.6 micromillimeters. Okay, to create this surface finishing on the 70 diameter, in the annotation tab, here we have the surface finishing. Click on it and click, for example, here, or also let me to find more space to create it. Okay, here, and okay, click again on the surface finishing sign and change it to here. The second symbol is machining required. In the symbol layout, you need to create or add an amount 0.8. Scroll down and change the size and font of these fonts. Time New Roman, and it should be 12. Click on it, Control C, copy. After that, 1 and 2. Let me check in. We have this surface finishing sign on 95. Drag and drop on this line and change the direction. Scroll down, and when you decrease the angle, it rotates. Here is 180 degree. Okay, it's reverse. Another diameter is here 105. Okay, change the direction rotation 180 degree. Okay, let me check. Okay, here we have the chamfer, 5mm is the length and the degree is 15. Is here. Dimension it here to here is 5mm. Okay, drag it to downside and the angle remains here to here. And drag it closer. Okay, let's do drag or increase the length of the shaft. Okay, it's better. Okay, here we have some fillets on this shaft. Let me check it. Here we have some fillets. We need to create it on parts environment. Here, fillet radius 2 all sharp. Edges need to radius 2. After that, let me check in here. We have the chamfer 2 in 45 degree. Okay, it doesn't create. Right click on this front view again, right click, and after that open the part. It's directly connect the part. Okay, go to the chamfer. Here change the amount 2mm and select this sharp edge. Okay, again select the fillet, change the amount 2mm and select all sharp edges. Here. And okay. Back to drawing. And just the chamfer and the fillets remains 2 dimension. Okay, as you see, some dimension turn into green. It means when I change the chamfer, the length of the dimension is to change. If it doesn't work, just delete it again and dimension it here to here, also here to here, and drag it a little here. Okay, there is a more space. Right click on this dimension and here break the alignments. When you break the alignment, you can't drag it just one dimension. It doesn't depend on any dimension. I can drag it here. Again, right click, break alignments. Okay, it's better. Click under the smart dimension to dimension the chamfer. The last feature is chamfer dimension. Click on it. You need to click the angle line, this line, again this line, and about one of the line, for example here, horizontal line. Okay, it's dimension the chamfer 2 in 45 degree. Change the leader. Custom text should be here, horizontal text direction. Click on a smart dimension to dimension it all fillets here and tap this point to reverse the flash. Okay. 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 Just it's a little crowd. Drag it the sign here. Again, drag it sign to here. Select the fillets and change the text dimension into horizontal. Also, you can drag it, for example, is here. Okay, but this fillet is a little has a space. Go to the other, change the fonts just for this radius, and the font should be 10. Okay, it's better. Okay, but this fillet, change it the direction of the text. Okay, let's drag a little the detail into downside to have enough space about the dimension. Right click on it and in the alignment select the horizontal by origin and select, for example, this view. Okay, drag it to down. Okay, we need to have the isometric view of the shaft. Go to the drawing tab, select the project view and select on this view it's create the isometric of the shaft. Drag it, for example, here to here, it's better, and click on it and it should be shaded with edge, and the scale is so big and let's change it into 1.5 and drag it here. Okay, this is a little I need to rotate. Click on this view. After that, select the rotate view and rotate about the 30 degree. Apply it. Okay, 30 is a little big amount. 15 is good. Okay, here we need to write the material and the specification of the shaft. At the left side, right click on this sheet and edit sheet format. Click on it. Right click on the 3 points and edit it to CK45. Okay, in a roundless, we use two surface finishing, 1 and 2. The one, all shaft need to machinery into 1.6 and change the font, Time New Roman. Okay, delete this surface finishing and click on it, Ctrl C, after that Ctrl V. Okay, click on this surface finishing and change the amount 0.8. Here on the below of the design, dot, parentheses, after that in right side, parentheses. This is the default of the drawing. Okay, after that the quality remains and the weight of the shaft is here, 108 kg. Again, right click on the sheet format, double click on the weight and change the amount, 108 kg. Let me check in again. Yes, and the title is shaft. The quality is 1. And we just drawing one sheet of one total sheet. Drag it a little to left. Okay. Okay. Just about the depth of the key. The slot is remains and here 0 the maximum tolerance, as minus 0.1 is the minimum. The second option, the types of the tolerance, was the bilateral, and they just change the minimum tolerance in, just read one word after the dot is 0.1 minus. Okay, click on the this tolerance, format painter, and just tap on the these steps. Okay, it's apply. To get the PDF of this drawing, Ctrl P, the print windows appears, and also here the icon of the print is here. Okay, in the name you can print based on your printer name. Also here we have the Microsoft Print to PDF. Click on it, go to the page setup. The setup should be at select to fit. Okay, the size of your paper is letter, and let to preview of this drawing. Okay, print, and so let me, okay, and it wants you to choose a location and shaft, for example 01. The PDF is created. To change the color of the dimension, for example, press Ctrl A. After that, in layer color, click on it. I define, for example, 0 is black. Okay, all dimension color change to black. To define it, select the design layer properties. After that, go here. I put change it. It's black, or you can change the color, for example, green, yellow, blue, anyone you want. Okay, and your layer is here. Click on it, and layer number 4 is the black, and for example 0 is the black color. Green, yellow, blue, anyone you want. Okay, and your layer is here. Click on it, and layer number 4 is the black, and for example 0 is the black color. This is based on a reality shaft we created on 18 kilowatts AC motor. This shaft is used for it. I try to learn all the tolerance in this practice. If you like it, don't forget to subscribe the channel. Please support me by like this video and share it to your SolidWorks guys. And if you have any question, just comments below the video, and thanks for watching.